Java Review Arrays. There are times in programming where we must store many values, not just one or two. In these cases, it is not practical to assign a variable or identifier to every value. For example, let's say we want to write a program that will store a student's grades for the marking period. There are 15 assignments. Would you declare 15 different variables? Furthermore, if you had a total of 80 students, would you declare variables for each of them? We can see how it is extremely impractical to declare such a vast amount of variables and be able to keep track of them. More importantly, even if we did, what would happen the next marking period? Would you create 15 new variables? Would you delete all the values stored in the first 15 variables? An array is a type of object. An object has attributes and behaviors. For example, a car is an object because it has attributes, weight, color, etc., and it has behaviors, drive, brake, etc. This is very unlike a primitive data type which only has an attribute. We will learn more about objects later on, but for now, let's take a look at one type of object, an array. Here is the syntax for declaring an array in Praxis code. We start with the data type, so the type of data that's stored in the array. Then square brackets are used to show that it is an array. Then we have the array name, we have the arrow, then inside curly braces, separated by commas, we have the data that is stored in the array. We could have also created an array of string values. So the data type is string, then we have square brackets, then name of the array, our arrow, curly braces, and then our data separated by commas. So the data in this case are strings. So inside quotes we have some names, Susan, Maria, Robert, Kate, and John. All arrays have positions, or what are termed index values, that indicate a position in the array. Below, you'll see our array guests and the string values that are stored in the array. If we think about the values stored in the array as having their own cell in a table, we can easily distinguish each of the values' index. So here, we see that the index values begin at 0 and continue counting 1, 2, 3, 4 until each value is assigned an index. So the first item in the array has an index value of 0, the second item has an index value of 1, and so on. We can access the values in an array by using the index value that each piece of data has been assigned based on its location in the array. So here we have an integer array called student name. We have 3 values, 95, 92, and 87. If we were looking for the value 92, we can create a statement that looks like the following. Int num is going to be equal to student name square brackets, and inside the square brackets we have a 1. We have to be sure when accessing elements in an array that we only use index values that exist in the array. For example, the statement student name 3 would produce an error. So remember, index values begin at 0. So 0 will access 95, 1 will access 92, 2 will access 87. So student name 3 would produce an error since there is no value with an index value of 3. When arrays are small in length, they're easy to work with. However, when they start to get bigger, working with them can get tedious. This is where loops come in handy. A for loop, or several, can help us do many things. Here are just a few. Search the elements of an array, change or alter elements of an array, and print elements of an array. Here we have an example of how to fill an array with numbers. So we have an empty integer array that has 5 compartments. So we're going to have a for loop that iterates through the array, filling the array with values. The first time through the loop, I is 0. So count down 0, so the index 0, so the first compartment in this array is going to be filled with 0 plus 1, 1. So that's how we get a 1 in the first box. The second time through the loop, I is 1. So count down 1, which is the second compartment, is going to set the value to 2, which is I plus 1, which is 2. This continues until all of the compartments are full. Let's try another example. Can you figure out what the output will be? All right, so here we've declared an empty array of 10 compartments. Now we're going to iterate through I is initially 0. We're going to go up to I is less than 10, and I will increase by 1 each time. So the first time through the loop, I is 0. So this is going to access the first compartment and set it equal to 9 minus 0, which is 9. All right, then I is going to increase by 1. So now I is 1. Now we're going to access the second compartment and set it equal to 9 minus 1, which is 8. So it's going to keep going through, filling each box like so. 4, 3, 2, 1, 0. And there you have it, 9 through 0. A two-dimensional array is useful for storing a matrix of information. For example, a 6 by 6 seating chart. Think of this like a spreadsheet with rows and columns. Just like with one-dimensional arrays, all the elements must be of the same type and initialized, otherwise the array is null. So here's the syntax for 2D arrays. We have two sets of square brackets, and then here we have one array, comma, a second array. So this would create a 2D array with 2 rows and 3 columns, like this. Each subarray's length can be used to find a specific element in that row. Provided an int 2D array as 3 rows and 4 columns, then x.length provides the number of rows, or subarrays. To find the number of elements in each row, we must specify which row we want by using x rownum.length. So here we would have x0.length is 4. The most efficient way to fill or modify the elements of an array will always be with a loop. In order to walk through the first dimension, use a for loop. Each element is no longer a single value. So here we have a 2D array, and we want it to have 3 rows of 4 columns. So for int row is 0, we're going to iterate through all of the arrays first. To process the second dimension, remember that the result of the first loop is an array. In the example below, a row, like this, is an array and therefore has a length. It is common to use nested loops when traversing a two-dimensional array. Also, notice the use of the identifiers row and col instead of our typical I and j. This is helpful when trying to keep dimensions straight. Let's take a look at how to fill 2D array num with 2 rows and 3 columns with the numbers 1 through 6 using the methods below. Each way has the exact same outcome. We can use curly braces and we can list values like this. So 2D int array num is going to be 2 arrays separated by a comma. Each array will have 1, 2, 3, and then 4, 5, 6. Notice the double curly braces that surround all the listed elements, along with the double curly braces that initialize each subarray. So we have a row here and a row there. We could also individually specify the elements by location. So we can declare this empty array with all zeros, then we can access each compartment and give them values that way. And here's another way using nested loops to fill a 2D array so that it looks like this. Let's walk through this code line by line together. We start out by creating a 2D array, we're calling it A, that has 2 rows and 3 columns. So remember, each of these arrays here counts as a row, and then the number of numbers inside of that row gives us the number of columns. So there's 2 rows and 3 columns. Then we declare a counter variable, x. That will help us fill up the cells with the correct numbers. The highlighted for loop right here is going to loop through all of the rows of the array. So it'll first loop through this row up here, 1, 2, 3, and then it will go through this row, 4, 5, 6. When we begin the loop, we are at row 0. Before we move on to row 1, we have to enter the second for loop so that we enter the 3 columns numbers, 1, 2, and 3. We are now inside the second for loop, which loops through all of the columns. When we first enter the loop, we're at row 0, column 0, the top left box of the 2D array up here. We set the value equal to x, which is currently 1. See how we declared that here on the second line of code. Finally, we increment x by 1 so that when the nested for loop starts again, we set the next box, the top middle box, equal to 2. Now after we have filled up all of the boxes, let's say we want to print them out so that they look like this, 1, 2, 3, 4, 5, 6. To print the array to the terminal window so that it looks like this, we use most of the same code. However, we replace the code in the middle, here, with a print statement that prints the contents of the box that we are currently accessing. Also, we included a print statement after the nested loop that inserts a new line. That will make sure every row shows up on its own line. So this print statement here is going to make sure that there's a new line before we start 4, 5, 6.